Welcome back, everybody, to another JavaScript tutorial, TypeScript tutorial, whatever you want to call it, inside of the Office API. In this particular video, we're going to be covering some of the fundamental concepts that we have to understand now that we're moving over from VBA to JavaScript or TypeScript. There's some things that behind the scenes we have to understand how these languages will behave in certain situations that can sometimes give us consequences. Well, not consequence, but basically they're giving us results that we were not expecting. And so one of the topics that we're going to be talking about today is asynchronous versus synchronous programming. And so at first, this might be some people find it confusing. I think you kind of have to look at it from different ways. I try to have some analogies or visuals that we can kind of reference and some mental cheats that we can reference that ideally will make this concept not so confusing. But if you don't get it right away, don't beat yourself up. Kind of watch this video, maybe watch another video on YouTube, get exposure to the topic, and then usually after seeing it a couple times, it makes a little bit more sense. Alrighty, so let's just start off with a definition first. Sometimes definitions are hard to kind of solidify a concept, but we have to understand really what we're talking about first before we can actually start building the analogy. So what's the difference between an asynchronous and a synchronous program? Well, when we talk about a synchronous program, what we're really talking about is the flow of a program happens on a main thread in sequence. And so that's one event right after the other one. So I load a data set. I parse the data set. I transform the data set. I do some calculations, and then I spit it back out into Excel. This all happens in sequence. So one right after the other, and it's on this main flow of a program. So my program is taking my data set, transforming it, and then spitting it back out. And it happens all in sequence. It's on a flow for the main thread of that program. And so we can have multiple flows, so multiple basically programs running at once, but then each one of those is going to be on their own little threads. And so each one of those is going to be their own little program that does maybe the same thing or a different thing, but they're all kind of isolated. They're all kind of their own little flow, and they're separate from each other. And so JavaScript and TypeScript are actually synchronous programming languages. However, there are situations where they will behave in a non-synchronous manner, so in an asynchronous manner. And so with an asynchronous program, multiple flows can happen at once. There isn't a main flow that the program follows. The important thing to note is that the program doesn't wait for the event to finish before moving on to the next line. To give you an example of this, let's just imagine for a second that we boot up our computer and then we load the data set. With an asynchronous program, it's not going to finish that one. Well, it's not that it's not going to finish. It's not going to wait for us to load the data before moving on to the next step, which would be to parse the data set. So even though that step hasn't finished, JavaScript or TypeScript is already going on to the next step. In some cases, that's okay. In other cases, that's not okay. And so what we're going to see is that we, in some cases, have to take the asynchronous program and make it behave in a synchronous manner. And we'll see the different options that we have in order to do that. So the way I like to think about it, at least my little mental cheat, I call it. So when I hear synchronous, I hear in sequence. And so for me, synchronous is in sequence, one right after the other. And once you know that one, you automatically know the other one, which is asynchronous. With asynchronous, it's not in sequence. And so things don't have to happen one right after the other. One thing can happen, and then another thing can happen both at kind of the same time. And so the idea with asynchronous is I'm going to go to the next step even though my previous step hasn't finished. Let's talk about analogy. So let's imagine we're baking a cake. In a synchronous program, it's pretty straightforward. We'll boil it down to just a couple core steps. We mix the ingredients, we turn on the oven, we bake the cake, and we frost the cake. That is our program. That is our program for baking a cake, and it happens in sequence, one right after the other. Now, we can have multiple people follow the same program, and so each one of these would be their own little thread in our program, and they all do the same exact thing. So we have Jacob's cake and Alex's cake. Each one of these is their own thread, but they each perform the same action. They both mix the ingredients, they both turn on the oven, they both bake the cake, and finally, they both frost the cake. So they all, again, happen in sequence. We're just having the same program run on multiple threads. We can also have a situation where we each have our own program. They still both behave in a synchronous manner, but they both do different things. So for example, Jacob's program is for baking a cupcake, and then Alex's program is for a cake. Now the cupcake, you've seen those little fancy ones where, you just mix the ingredients, you put it in the microwave, and then lo and behold, you're done. So that's kind of the analogy I was trying to go with the cupcake one. But you can see, again, they're still happening in sequence. They're on separate threads. But the main idea is that they're happening in sequence, and that it's saying that, hey, they don't have to be the same thing to be on different threads. They can be both doing different things. But the idea behind it is they're still synchronous, but they're just running in parallel. I mean, visually, you can even see it's parallel, two parallel lines. But then we get the asynchronous behavior. Well, say for example, we kind of switch around our little program a little bit, and the first thing we do is we heat up the oven. Well, our program isn't going to finish, it's not going to wait to finish the heating up the oven. So for example, even though we heat up the oven, our program's not going to wait for it to finish heating up. What it's going to do is it's going to jump to the next step, which is mix the ingredients. And so it mixes the ingredients, and then the next step is the oven will hopefully by that point finish heating. And then we can then bake the cake and then put frosting on it. The idea that you should be taking away from here is now we still have this kind of single thread, but there's multiple things that are happening on this particular thread. And so the first one, the heat up the oven, JavaScript is still doing that behind the scenes, but it's not waiting for that event to finish. It's moving on to the next step, which is mix the ingredients. And so again, sometimes this is okay, sometimes it's not okay. We'll see, especially with the Office API, it does get us into trouble sometimes when we want to, for example, call the properties of an Excel object. We actually have to put a step in our program where we tell JavaScript or we tell TypeScript, wait till you get a result before you move on to the next step in this program. So this would be an example of an asynchronous program. Again, there is a step that is not finishing before we're moving on to the next step. But at some point it does finish, and we then continue on in our program. So again, this is kind of how I like to think about it. I know for some people they might have a better way of doing it. Do whatever works for you, but have some kind of framework in your mind that kind of help understand what's really going on behind the scenes. And a lot of people ask, well, why would we even want an asynchronous program? Like, what's the benefit to having an asynchronous program? Well, probably the first thing that you'll notice is you're basically maximizing your resources. You're not letting your resources stay idle. For example, if we waited for our program to finish heating up the oven, our resources would just be laying idle when they could be used for doing other things, maybe loading in a data set, maybe, creating a new graph or something like that. In some cases, it makes sense to make sure our resources aren't idle because it's making sure our program runs faster, not necessarily run fast, but it basically finishes quicker. And this is great for things like web page. We don't want to sit there and be waiting for a web page to load for 30 seconds when really 20 seconds of that is dedicated to just loading the data. Why don't you load the images while you're waiting for the data to load? So that's really the idea behind it. Is it's supposed to be making our programs kind of not let the resources stay idle. It's supposed to be using them in the most efficient way possible. However, there can be some situations where this doesn't make a lot of sense and it can get us into trouble. And again, this is just another way for you guys to see it. This is kind of a more formal one where we're not putting an analogy behind it, but you can see a synchronous single thread. We can have a synchronous multi-threads. Again, one can finish before the other or so on and so on, but the idea is that they're running in parallel, and again, they're happening in sequence. And then again, we have an asynchronous behavior where, again, an event might happen, but we're not waiting for that event to finish before moving on to that next step. It might finish later on in our program. That can be a good or a bad, but we'll see kind of where this comes into play later down the road. Okay, so In some situations where we know maybe JavaScript or TypeScript, we might be knowing that, hey, it's behaving in an asynchronous manner. How do we make it behave in a synchronous manner? Like, for example, we need to make sure that we get our result back before we move on to the next step, or basically we're going to encounter an error because it's going to be trying to parse a data set that technically hasn't been loaded yet. So how do we make JavaScript synchronous when in certain situations it wants to behave in an asynchronous manner? Well, there's a couple options we have. We have something called callback functions, and we'll explain what that is in a second, promises, and then an async and await. And so basically, I can kind of tell you right now, in most of my tutorials, we're going to be using the async and await method just because I think it makes the code look a little bit more cleaner, at least just from my experience. But you can technically use any of the methods that I'm going to be showing you. You just have to understand the strengths and weaknesses of each one. Okay, so the first one that we're going to talk about is a callback function. What is a callback function? Well, basically, JavaScript leverages a function that will be executed once a result is ready. This way to know when an async operation has a result. The result being either data returned or an error that took place during the operation. This is what we call a callback function. And so, again, the important part to understand here is it's going to leverage a function that will be executed once the result is ready. How is this fixing the async behavior? Well, because we're waiting now for that result to kind of come back to us, we've fixed the problem of the program wanting to jump ahead. This function basically is requiring us to wait for that result to be sent back to us. So we're stopping the program in a sense before moving on to the next component. However, there is a drawback to this. It's called callback hell. In simple situations, having a callback function is fine. However, if you have a function that depends on one function and then another function and another function and so on, all of the sudden your code can become very, very nested very quickly, and it's very hard to decipher what's really going on behind the scenes. For example, maybe I have an outer function called myAwesomeFunction. It takes an input parameter x, and then it's supposed to be parsing that the next function, my second function x, which is again dependent on a nested function, my third nested function, which then takes a function z, and so on and so on. You can see here that all of the sudden, as we're trying to do more and more complex things, our program becomes very, very nested. And this is going to create a problem where it's going to be hard to decipher what's really going on behind the scenes, because now you want to do complex things, you're going to have these really complex nested functions. And so again, readability kind of goes down the drain in the process. But the idea here is that you can see that function x, well, we'll start inner, but basically the second function is depending on that nested function. So it's basically taking the results of that, and it's not going to go on to the myAwesome function until my third nested function has finished running. So again, it's dependent on the function on the inside finishing before we go on to the next one. And again, there also might be a situation where an error happens at the second one. And again, it's just kind of hard to decipher really what's going on behind the scenes. Okay, so there's callback functions. They're okay, but they can become a problem. That's where promises were kind of created out of this. A promise is an object that wraps an asynchronous, I'm going to tongue twist this all day, I swear to God, asynchronous operation and notifies when it's done. A lot of people, they kind of say, well, isn't this kind of just like a callback function? It kind of sounds like it. Kind of, but the important differences are in the usage of a promise. And so a promise uses its own methods to tell the promise what to do when it was either successful or it failed. So now we're incorporating two new methods to an object that will basically say, well, when you're successful, do this. When you're not successful, do this. So now it's basically better at error handling. And so it does that by using that then method for when there's a successful result, it just does the components that are inside that section. And when it's not successful, it uses the catch method for when something goes wrong. So it's adding a little bit more structure. Again, it can still be a little bit hard to read sometimes, but at least we're building a framework where we can handle successful outcomes and we can handle not so successful outcomes. And it would look basically something like this. So imagine we took um, our example out there and we said, well, we have our awesome function, and then what we're going to say is, well, take my awesome function, then run the function inside that, return my second function, then take that function, pass it through to my third nested function, then take that result and log that final result. So you can see here it's basically chaining on each of the nested functions. So it's saying my awesome function, then my second function, then my third nested function, and then take that final result and log it to the console. But then you can also see at the bottom there is something called catch, which is basically, hey, if anything goes wrong, just put it through the catch method and then log that error so we can see it. So again, the idea behind this is we've added some structure so that way it's a little bit easier to read, and now it's kind of just chaining off of each other. So now we're not having this nested component, but we can say do this, then do this, then do this, then do this, and then if there's an error, catch it. Alrighty. So I found this nice little definition online. I think this guy really did a great job when it came to explaining it. So I put a link down below. Again, to me, I was like, okay, this guy, perfect definition. So I just kind of had to give him credit. I was like, dude, this guy's got it. Okay, so the async keyword within TypeScript lets us define an asynchronous function. So again, a function that is not going to be happening in sequence. And then we can tell this asynchronous function in such a manner that its execution becomes synchronous. So again, we're defining an asynchronous function, one that is not going to happen in sequence, but because we've identified it like that, we now get access to some other keywords that will allow its executions at the points where it wants to behave asynchronously. We can now tell it, hey, behave synchronously. By doing this, we can write our code that is far cleaner and more understandable than our chained promise example. It allows us to utilize the await keyword in front of an expression that will return a promise and pause the execution of the function until the awaited promise resolves with a result. So the key thing here is we're going to use something called the await keyword, and when we have the await keyword in front of an expression, behind the scenes, it's going to wait for that expression to resolve itself, and whether that's with a result or an error, before moving on to the next step in the program. So again, very useful, very helpful, I think, in the sense of understanding it. Again, it might seem a little bit hard at first, but at the end of this, we're going to actually jump into Excel and we're going to see it in action. And so really what's happening is you would be taking your promise object, so the one that has then, catch, and it would look something a little bit like this. So you would define your functions. So my second function, my third nested function, you would define what each one of those do. You would then define the master function, the my awesome function, which is the one that encapsulates those two nested functions. And you would write it like that. And then you would have your final variable equal promise, which is the main outer function, and then you would console log the result. And so me personally, I do like the right side. I think that makes a little bit more sense, in the sense of I understand the different module components. The reason the left side might say, well, that actually looks a little bit easier, right? Kind of. Again, it depends on the complexity behind it. I personally like the right side just because, again, it's a little bit easier to understand what's going on behind the scenes, and I can see it in a more compartmentalized framework compared to just everything thrown together at once. Notice how it's using the async keyword and the await keyword to define the asynchronous functions, and then more importantly, using the await keyword to make sure those asynchronous functions behave in a synchronous manner. Very useful. I'm going to be putting in some resources below for everybody, just in case they're curious, like, hey, how does this all work? Again, I'm one perspective. You should be trying to look at as many perspectives as possible. It's just, again, to help either reinforce the idea, or if you're still confused after this video, maybe just see how someone else putting it kind of in a different framework and seeing if that maybe, hopefully, lets it stick. Alrighty, so now that we've done that, let's jump into Excel and kind of just see this in action. I already have a program built out for us, but I just want to let you guys know and kind of see where asynchronous behavior can not necessarily give us a wrong result, but give us a result that we weren't necessarily expecting. So right up here, just to kind of give you a little bit of an idea of the background, I've defined two functions. Both of these are an async function, and so basically what we're saying here is with the async function wait, I'm just going to be pausing my program for X amount of milliseconds. And really all this is doing is it's taking the set timeout function and it's passing through the amount that we specify in our wait function. Really all that you need to understand about this little function up here is it's pausing our program. We'll see why this is important when we get to our main program. So this is our little main function. I call it show async wait. And really all I do is I just define some variables. These are all basically numbers, nothing fancy. And then I define two little functions. One is function 1, which simply takes a number and then returns 5 times that number. And then I have a second function, which just simply returns the value 10. So function 2 just returns 10. Function 1 simply returns 5 times whatever number we pass through. And then at this line below, I am going to console log, or just print out over here at the console log, the result of function 1 where I pass through the result of function 2. So really with this one, we would expect it to be 50. And then I print out variable A and variable B. So for the most part, this should be really understandable, but the important thing here is this is a synchronous program. So these lines of code will run, these will run, and this will run, and these will run as well. So this is a synchronous program. It's happening one right after the other. There is no asynchronous behavior. And again, just so people who are maybe unfamiliar with this add-in, this particular add-in script lab gives us different panes. That gives us the different code of our quote-unquote add-in. The HTML, I'm just defining my button. It's got right to counsel in it. And then there's a little header section up here, try it out. Our CSS, that's just, again, defining some of the margins and display and stuff like that. Our libraries and all of that fun stuff. So really what I'm expecting when I click this button is that it again prints out the results of function 1 where we pass through function 2 and log A and log B. And if you go over here, it behaved just like we were expecting. We got 50, 100, and 200. So this is an example of a synchronous program. It, again, one right after the other. Now let's see what goes on here. We're going to do this first. So I have a set timeout function, which will simply pause. In this case, even if I'll just leave it just like it is for right now. But basically, it's not actually going to parse. But all it's going to do is it's going to take my C variable and it's going to increment it by 1. So this is going to pause it for 10 milliseconds, and then we'll log the result of C. When I'm looking at this at first, I'm saying, okay, well, if I'm incrementing it by 1, I should expect 300 plus 1 to be 301. So I'm expecting 301 here. Well, that's a little odd. It's 300. That is definitely something I am not expecting. Why is that? Why is this happening? Well, this is now where we're going to asynchronous behavior. JavaScript or TypeScript in this example is not waiting for this line to finish. It's executing it, which it did, but then it jumps immediately to this line. Well, this one is still referencing the old value because this one actually never finished. This is the problem with asynchronous programming sometimes. We wanted 301, but we got back 300. It's because this line never actually finished. It started and it finishes at some point, but it finishes after we log our counsel. We counsel log our C variable. So in order to fix this, what we can do is we can pause our program. And so what we're going to do is we're going to call another function up here, the await function, and then well, it's not await, but it's called wait. And then we're going to use the await keyword, which is basically going to say, do not go to this line until this line is finished running. And so hopefully that fixes our issue, and we should now see 301. Oh, it didn't look like it did it. Let me try that one. Perfect. Okay, so now it worked. Sorry, I didn't change that little component down here. I was keeping the same old value. But with this one, now it actually had time to finish. Again, if I put it back here, we can see it's still 300. But now when we pause the program like we want, now we get the result that we were expecting. And so again, I had to change my value here. I was using an old one, but really the important key takeaway here is that I use the await keyword to say, wait for this result to happen before you console log the result. And so this is basically making sure that the results of this one have actually taken place before you start console logging it. And so this is how we take an asynchronous behavior and turn it into something that behaves synchronously. Now, technically speaking, what you could do is if you were to put the console log inside of this function, we would actually get the result that we were expecting, because part of this function is now actually executing that console log. So in order for this function to actually finish, it actually has to print out something. And so with this one, we get the result that we were intending, but that's because we're doing it inside of the function. If we were to do it outside of the function, then we get that asynchronous behavior that really we weren't expecting. So really the purpose of this was kind of to demonstrate where that asynchronous behavior can give us some, again, it's not that it's the wrong result, it's just the result that we weren't expecting. And we have to understand why it gave that result to begin with. So that actually does it for this video. If you have any questions about asynchronous behavior or synchronous behavior, please put them down in the comments below. Again, I'm expecting a lot of people coming over from VBA. This is new, I'm sure, to a lot of you, but this is a core concept that you have to understand about TypeScript and JavaScript before you start coding with the Office API, or else you're not going to be able to understand why you're not getting the results that you're expecting. So it's a very important concept to understand, but hopefully after this video, you now have a little bit more of an understanding about why it behaves the way it behaves. So again, if you have questions, please put them down in the comments below. Also, if you could, please make sure to like the video. We always appreciate the support. We want to make sure other people can find it. And if you're not already, please make sure to subscribe to the channel so that way you get regular updates as we release new videos. In the next video, we are going to explore the workbook object, and we're going to see how to use methods and properties related to our object. So we will see you guys all in the next video.